Sir,
Yeah.
sequences and series are on the test, right?
Nope.
Oh, no, okay.
Just on the exam. Okay, and on the quiz. We're gonna have a second quiz. So series. So an infinite series, okay, or just a series. Okay, we write just series. Is the sum of all the terms of an infinite sequence. Okay, so let's say a sequence AN, like this, with n starting at 1, let's say. Okay. Or it could be starting at 0, or it could be starting anywhere. Okay. But I'm interested in adding all the terms. Okay, so for example, the series like this, the sum of all the terms, let's say from n is equal to, let's say 0 to infinity, 2 times 1/2 to the power of n. Okay, what's it going to be? Well, I'm going to plug in n is equal to 0. I'm going to get 2 times the half power 0 is 2. Plus, when n is 1, so 2 times 1/2 power 1 is 1. Plus, when n is 2 times a quarter is 1/2. Plus, when n is 3 is 2 times 1/8, which is a quarter, and so on. Plus, when n is 4 is 1/8. Plus, keeps going. Okay, you keep adding like this forever. So 2 plus 1 plus 1/2 plus a quarter plus 1/8 plus 1/16, 1/32, 1/64, and you keep adding. And you will see that if you try this on the calculator, you start adding maybe after 10, 15 terms, you're going to notice that you're getting closer and closer to 4. This sum, no matter how many numbers you keep adding, you'll never exceed 4. Okay, why? I'm going to show you why soon. Okay, but this for now, just to understand what a series is. So these are all the terms of that sequence: 2, 1, 1/2, 1/4, 1/8, and now we're adding them. That's what it's called a series. It's just a sum. Okay, another example. Let's say sum n equals 1 to infinity of 1 over, let's say, n2 plus n. So same idea. You plug in 1 here, you will get 1/2. Plus, if you plug in 2, you get 1/6. If you plug in 3, you get 1/12. 4, you get 1/20. 5, you get 1/30. And so on. And you will get about, this is going to get closer and closer to 1. Okay? Okay, any questions on what series is? Okay. So, of course, these are series that are very nice and they get close to a number. Some of them don't get close to a number. Okay? They go on forever. I mean, they all go on forever, but when you add them, there is no number that the series cannot exceed. It could happen. Okay, and these would be what we call divergent series, and we're going to talk about convergence right now. Okay, what does it mean that a series converges? Okay, so let me write this down. A series, let's say sum n equals, let's say 0 to, let's start at 1, who cares? Okay, it doesn't matter for now. 1 to infinity of an converges. To a limit L if the sequence of its, so a new term here, partial sums converges to L. Okay, so that's what it means for a series to be convergent. Okay. Okay, let me explain this to you. Just waiting for you to write. Okay, so a series converges to a certain sum or limit L if the sequence of its partial sums converges to L. So I don't know what a converging series means for now, but I do know what a converging sequence means. We just talked about that last class. Okay, the sequence converges if you could get as close as you want to a certain limit, or we just evaluate a limit at infinity, just like we did before this class, okay, today. Okay, so I know how to evaluate the limit of a sequence. I don't know how to evaluate the limit of a series. So what I do, I'm going to create a sequence based on that series, which is called the sequence of its partial sums, just like what I'm going to show you right now. Okay, so I'll show you this with an example. Okay, so here's an example. So I'm going to use the same I did in the example before. So consider the series, okay, with the infinite series. So sum n is equal to from 1 to infinity, 1 over n2 plus n. Okay, so does the series converge or diverge? Okay, and if it converges, find its sum. Okay, that's a question. Okay, so that's a question. You're going to get something like this on the test, on the quiz, guaranteed. On the exam, not on the test, and on the exam, or the quiz. Okay, on the test, it's not a test. Okay, so what I'm going to do is I'm going to create the partial sums. Okay, so we write the partial sums. So I'm explaining right now what a partial sum is. So the first partial sum is S1. Okay, sum 1 is just the sum n goes from 1, and now instead of going to infinity, I'm just going to go until 1. Okay, of this term, right? Of this series. So basically, I'm just taking the first term, which is 1/2. Okay, then I'm going to do the second partial sum, S2, which is going to be the sum, n goes from 1 down, I'm going to go until 2. 1 over n2 plus n, and so now I'm going to get 1/2 plus, and now when it's 2, I'm going to get 4/6. So I get 1/2 plus 1/6. You get it? S3, sum n equals 1 until 3. 1 over n2 plus n. That's going to be 1/2 plus 1/6 plus, and when it's 3, it's 1 over 12. You understand what I'm doing? Okay, so S1, S2, S3, so the first term, the first 2 terms, the first 3 terms, the first 4 terms, the first 5 terms, and so on and so on. And I'm going to generate a sequence like this. Okay, these are all partial sums. Okay, S1, S2, S3, all the way until Sn, until S infinity, actually. Any questions? Okay, let's see what these are equal to. S1 is equal to 1/2. S2 is equal to, so 1/2 plus 1 over 6 is 3/4 over 6, so 2/3. S3 is, let's find the common denominator here, so 6 plus 2 is 8 plus 1 is 9, 9 over 12 is 3/4. Okay, I start to see a pattern here, 1/2, 2/3, 3/4. What's the next one?
4/5.
4/5, 5/6, 6/7. So I'm starting to see a pattern here. So I could find a general rule here. Okay? I could, if you're not convinced after 3, nobody stops you from going until 20 if you want, until you're sure of the pattern. But here I see 1/2, 2/3, 3/4. Can you tell me what the general rule for Sn will be? Somebody give me the general rule. What is it?
Over n plus 1.
What do you say? N over?
N over n plus 1.
Very good. N over n plus 1. Any questions on this? You good? Yeah.
So each like S1, S2, S3 is the series only up to a certain number. Is that what I'm?
Exactly. S1 is the series until the first term. S2 is the series until the second term. S3 third term. Sn, the first n term. So the first n terms apparently will add up to n over n plus 1. Good?
Yeah.
Questions? Anyone? Okay.
Sir,
Yes.
the first entry here, for example, is going to be 1/2.
Yeah.
Okay.
Yeah. What? Which one?
No, I just like, so we take the n as 1/2 and then we put it like on 1/2 plus 1, right?
Plus 1? What do you mean plus 1?
It's the rule, the Sn that we found. N is equal, Sn is equal n over n plus 1.
Yes.
So to try it's right, we take like the 1/2. So we do 1/2 over 1/2 plus 1 and we get.
No. Not at all. Okay. what I'm doing here is like this. Okay, my series goes 1/2 plus 1/6 plus 1/12 plus 1/20 plus 1/30 plus 1/, I think it's 42, I'm not sure. Yeah, 1/42 plus 1/, I think 56 plus and so on. Okay, that's my series. Okay, if you expand this, that's what you'll get. You okay?
Yeah.
That's my big sum. It's this. Now, my partial sums. So if I could represent it like this. This here, S1. These two, S2. These three, S3. These first four, S4. Understand?
Yeah.
This is S1, S2, S3. These are the partial sums. So the first one is just a half. S2 is the sum of the first two, is going to be 2/3. The first three, if you add them, you get 3/4. If you add the first four, you're going to get 4/5. You understand?
Yeah.
So if you add the first n terms, let's say continue until the nth term. Okay? So if you add the first n terms all the way until here, you will get Sn. And apparently, it's always, the pattern is, it's going to be equal to n over n plus 1. That's all, that's what I'm saying.
Okay.
Clear?
Yeah, just a quick question. To be sure, like it's what we're doing is right. If you want to take a number to be sure it's right, like to take an n, which n would we take? We can't. Okay. Perfect.
You
Thank you.
could maybe show it, prove it by induction that this is good. Like we proved by induction at the beginning of the course, but you're not going to be asking this, okay? So if you see after 4 or 5 that you recognize the pattern, anyways, we're not going to use this, okay? It's just, I'm just illustrating this to show, to show you what a partial sum is.
Okay.
And you will see that, you'll see what's going to happen very soon.
Perfect. Thank you.
Okay, so let's keep going. And now what did I just find is that Sn, the sum of the first n terms is n over n plus 1. So let's go now and answer my question. So sum n is equal to from 1 to infinity of 1 over n2 plus n is equal to, okay, so if I do the sum from n equals 1 until, let's say, k, I don't know, k, okay, 1 over n2 plus n, and I make k go to infinity, it's the same thing. Okay, going from 1 to infinity or going from 1 to k, but k goes to infinity, same thing. Okay, and that's equal to the limit as k goes to infinity. What is this? This is the sum of the first k terms. Okay, so this is your partial sum until k. Okay, this is as k. And this, we just showed that Sn is n over n plus 1, so Sk is k over k plus 1. So this is limit k approaches infinity, k over k plus 1. And now that's a very easy limit to evaluate. It's infinity over infinity, you could use L'Hopital's rule, whatever you want, and I get 1. Okay, so this series here, my series converges to 1. Write it down. So the series n equals 1 to infinity 1 over n2 plus n converges to 1. problem is that finding this pattern, right, to find the general term of your partial sums, which in this case was n over n plus 1, it's not always going to be as easy as this. Okay, most of the time you won't be able to find this term. Okay, it's pretty complicated. I chose this example in a way that it's easy. Okay, but most of the time it won't work. So we have to do it another way. And I'm going to show you right now how to do it. So I'm going to redo this question, okay, using the way that you're going to use. Okay. So here's another way to do this. And that's the way we're going to use, that you're going to do every time I'm going to ask you to find the sum of a series. There's going to be two types of series. Either this one, this type of series, which I'm going to give you the name in a minute, or the geometric series, which is the next one I'm going to show you. Okay, so this is what you do. 1 over n2 plus n. That's the same thing, right? The denominator could be factored, n over n plus 1. Okay, do you remember something like this in integration? When we had the denominator to be factored, what would you do?
Partial fractions.
Very nice. So let's do partial fractions. Okay, so A, B, right? Remember this. And that's the same thing as you find the common denominator. So I'm going a bit fast because you're good at this by now. B times n, and on the bottom I have n2 plus n. Okay, so 1, basically this means that 1 has to equal to A times n plus 1 plus B times n always. So let's say if n is 0, n equals 0 means that A equals 1, and then if n is negative 1 means that B is equal to minus 1. Okay, so the series becomes, so the sum n 1 to infinity of 1 over n2 plus n is the same thing as the sum n1 to infinity of A over n, which is 1 over n, plus B, which is minus 1 over n plus 1. Okay, so I rewrote my series, my general term of my series, into a difference of fractions using partial fraction decomposition. Okay, I'm going to write it here just for you to remember. This is partial fraction decomposition. Okay, and now that I've decomposed in partial fractions, now I'm going to find my partial sums. And now you're going to see the pattern is much, much easier to recognize. Okay, so let's go. S1 is what? What's S1? Can you tell me?
Or 2.
What's S1?
1/2.
Okay, but let's leave it using this. So 1 over 1 minus 1 over 2. So 1 minus 1/2. Is that okay? What's S2? So I plug in 1, which is 1 minus 1/2, plus, and now I plug in 2, I get 1/2 minus 1/3. You okay? What's S3? So S3 is 1 minus 1/2 plus 1/2 minus 1/3 plus, if I plug in 3, I get 1/3 minus 1/4. Let's do another one. S4. S4 is 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus, and I got a 4, I get 1/4 minus 1/5, and so on and so on and so on until I'm going to try to find a general term for SK. Okay, any questions? Okay, so the S2, as you see, -1/2 plus 1/2 is out. S3, -1/2 plus 1/2, -1/3 plus 1/3 out. S4, the half, the third, the quarters are out. So this is very, very convenient for us. Okay, because what do I get? I get that S1 is just 1 minus 1/2. S2 is 1 minus 1/3. S3 is 1 minus 1/4. S4 is 1 minus 1/5. And so SK is what?
One minus 1/k.
Really?
1
Is
over
it-
k plus 1, I think.
1 over
K plus 1.
k plus 1. Right? You okay? You understand why it's not 1 over k? Because S4 is 1 over 5 here. So it's always the k plus 1 here. Okay, if it's 3, it's 1 over 4. If it's 2, it's 1 over 3. So if it's k, it's 1 over k plus 1. One more. Okay, so now this, of course, the same thing, right? 1 minus 1/2 is 1/2, 1 minus 1/3 is 2/3, 1 minus 1/4 is 3/4, 4/5, just like that before. But this pattern will be much easier to recognize than if you simplify everything you calculate, okay? And then the rest, we do the exact same thing as before, okay? Which means that the sum that I'm looking for, n goes from 1 to infinity of 1 over n2 plus n is equal to the limit k approaches infinity of the sum n equals 1 until k, which is the same thing as the limit as k approaches infinity of sk, and that is equal to the limit as k approaches infinity of sk, which is 1 minus 1 over k plus 1. And of course, this is 1 over infinity is 0, and so I get 1 minus 0 is 1. Same answer as before, which pretty much confirms that I'm on the right track here. Okay, so this type of series, okay, where when you do the partial sums, when you write down the partial sums and almost all the terms cross out, okay, this type of series is called a telescoping series. Okay,
So in a question like this,
Yeah.
we only do this method and not the other one.
the other one will almost never work. This one will work. Okay, so there's only 2 types. We're going to do a lot of series, but there's only 2 types of series for which I'm going to ask you to find the sum. And these are the telescoping series, which is the one like we just did, and the geometric series, which is the one we're going to do right now. Okay, or I don't know if we have time, but the next one we're doing is the geometric series. So on the exam or on the quiz, if I ask you to find the sum of the following series, you know that we're talking about telescoping or geometry. Okay, so telescoping is pretty easy to recognize because you have to do the part either decomposing partial fractions or right away do the partial sums and recognize that terms will cancel. And the geometric series is another type of another form of a series that you will recognize easily as well. Okay, any questions? Okay, so this one without explaining, just done right now.